I'll be talking about global interpreter lock, and I'll try to achieve some performance boost up in Python. So I was trying to do something and I came across a problem. It's like a lot of problems are happening in life, and thanks to God who has given us a lot of things to tackle around these situations. So one of the problem, I really work a lot of time in web development, and I came across with, something sort of okay, do something, and then Python is really not giving me that much speed. So I'll tell you one of the story, and for telling that story, I'll go back to one of my demo here. So it's connection closed. Okay, so so sorry. Okay, so I have my screen off now. It is visible. I will try to Okay, so sorry to keep you waiting for this time. And okay, so I have some of the programs I was writing, and then I'll. So let's say if you will talk about, I have one program which is doing some countdown operation starting from 100 million and then going till 0. And I have some multi-threaded version of this program as well. So what I observed in Python is like when I did Python 2.7 serial.py, it took something 8.04 seconds. And I have another version of this same program, some multi-threaded. I'm using 2 threads now. And it is 10 second, 10.6 second. So, do you understand the problem? So I was trying to get some parallelism and get the performance benefit, but it was taking me the other way around. So, are you aware with this problem? How many of you have used multi-threading? Okay, I mean, how many of you are aware with GIL and Python? Okay. So, I have one more program here which does nothing but only spins the CPU. And you can see here I have 4 CPU in my machine, and I have a magic I can do. So now I have only one CPU. Did you see the magic? So in life it's like every time I come across some of the magic, and when I try to solve that, it converts into logic. So like VMware from last 2 years is giving me lot of magic, and I am trying to solve it and understand the logic. So vSphere, you see here in the t-shirt, is having lot of magic for me. So as I disabled my CPU, I have one CPU, and I will run the program again. Python multi-threaded. Okay. Oh. So when my machine was strong enough and having 4 CPU, it was taking 10 seconds, 10.69. And when I have only single CPU with two threads, I'm getting 8.49.
Was it vCPU or was it physical?
It's a virtual machine, but you can think it's as a hardware. I mean, it's
So physically there was one before or
so right now I have only one CPU. Like it's my machine is having lot of, but lot of things is like ESXs and then virtual machine. You can create an n number of virtual machines on top of it. So there is a altogether very different topic about virtualization. We can talk differently. So I can tell you one it's one slot CPU I am requiring, and I can create 4 CPU out of it, right? So here we have seen that like if you have one CPU, you are gaining the performance over that when you will have a multiple CPU, but not the performance over this single threaded in the first example, right? So now I will do again one magic to do enable my CPUs back. So I have 4 CPU now, right? And now I'll show you that the program I have written, spin.py, what it is doing, it is acquiring one of my CPU, and it's 100% blocked, right? The 4th CPU. So I'll close this program, and I have one of the program which have what it is doing, it is creating multiple process of that spin.py. So let's say I have 4 CPU, it is doing n-1 times that process, and then running my threads after that with 1 CPU. So Python, I will do that, empty spin.py with 2 threads. See, have you seen the performance? Oh, okay, sorry. It's down here, you can see. .26. So it's is like serial programming was taking 8 seconds and now it's taking 6.2 seconds. So another time when you will go for code review, you will see, okay, I have an idea. If you have 4 CPU, block all 3 CPU other than one and work on only one single CPU. Will you do that? No. So let's go back to our talk then. I mean, this is related to how I reached so far. I will be talking about these topics, and then. So what is this? Let's understand about thread and multi-threaded programming a bit, because a lot of people are not aware of it. So what is this? Can we think about, this is a thread, fiber thread, right? So let's think this needle as your CPU, and thread, which is a set of instruction given to CPU for execution, right? So what will happen, I tried to stitch one of the cloth and I'll use this needle. Sometimes your mom would have told you, okay, can you put this thread inside the needle? You would have told like this, right? So in this needle I'm going to use as a CPU, and then I'll stitch one of the cloth. So what do you think? I have a lot of threads, right? I mean, thread, if I'll split and I have 2 needles, I will be able to do the job faster, isn't it? If 2 needle will try to stitch from both the end, it will be faster. And think about some I/O operations, right? Your CPU is executing a lot, and then I'll talk about it. So I/O operations, in case of, let's say you are tagging one of the button on the shirt, and then your one needle has to, one needle need to do that tagging. And if you have only single, so then the prime job of doing stitching will be waiting till the time that tagging of button has been finished, right?
Yes.
So this is the machine which comes with a lot of threads and lot of needles like CPU, and it can create a beautiful design in minutes, isn't it? So now I will be talking about CPU scheduling. I think everybody is aware of it, but even I'll give 1 minute to this. When thread, which is a set of instruction to execute by CPU, it came, and then CPU it's in new state, and then CPU admits it, and then it goes to ready state. As soon as CPU finds time to give the time slot to this thread, it will go into running state, and if it has completed its execution, it will go to the terminated state, right? And if another thread coming with the higher priority, preemptive scheduling, you would be knowing, right? So in that case, this running thread will be going to ready thread again, and if there is some I/O operation to happen on that thread, it will go to the waiting state, and then again from waiting to ready state when the I/O operation is finished, right? So this is the thread I was talking about. This is thread and the process. So process is an instance of program which is running inside your operating system, right? And the thread, which is a set of executable instructions, it can be given to one CPU only, right? So what about Python threads then? So Python also uses the real system threads, which is POSIX in case of Unix, and Windows thread in case of Windows. And that is fully managed by operating system, right? And your interpreter, Python interpreter, how it is working. So your interpreter, how it is working, it's like it it tries to do multiple things. Then the problem comes that okay, so Rivas was talking about reference count update, right? So what will happen when you will try, two different thread will try to write the same memory location? And one more thing I would like to tell you before going ahead is like process is the instance in which multiple threads can work together and they will be able to share that heap memory. And they have, if you will talk about global variables, they are sharing that space. And if you will talk about local variables, all the threads are having their own, right? So this comes this comes in the mind that okay, if you want to do such thing, when it should not happen like two threads doing simultaneously something, and then it should not break the system. So in that case, we need thread safety feature. So you would have encountered a lot like, okay, this is it this class or is this library thread safe? So what is thread safe? So it's like piece of code is thread safe when it functions correctly, even if it is going to execute it on multiple threads simultaneously. Simultaneously, I mean, we'll talk how deft we will be, and it must satisfy must satisfy the so let's say there is one shared data, right? And then multiple threads are trying to access it. It should be accessible. But no thread, it's like one single data will be not written by multiple threads at the same interval of time. This is thread safe. And it comes when I was talking about the performance I was not getting in my program. So this is because of that feature, GIL. So it's a lock your interpreter is having. So your Python program is running inside an interpreter, and that interpreter is itself locked. It can execute only one thread at a time, right? So it's why this lock is necessary in Python? Why C was not having something, and Java is doing multi-threading programming very well. So it's like, where do you want to put the lock? So let's say let's say there is a queue. This is your interpreter, and in JVM also, in Java JVM also, we have something like that. And then here you are passing a lot of instructions, and the libraries there in Java will have locking mechanism is required everywhere. I'll talk about that, and it can do locking here in the fine-grained level. But Python uses it to lock interpreters, so that lot of libraries which has been used from C, which is not thread safe at all, we will be able to use it. Do you understand what? So it's a problem like a lot of unthread safe code I have, which is bundled into Python library, and because it can, if you will say that okay, two threads are running at the same time, it can handle some situation where the problem will occur. So Python interpreter itself lock you and do this. So what it's like, you have multiple threads, and one of your thread is running, and it encountered a situation where it has to perform some IO operation, and then it will release that lock. So that lock, what is that lock? Actually, this is mutual exclusivity and exclusive. So if you have came to VMware, right? How you came to VMware? Either by this Dalmia circle or this way. So in Bangalore, what happens if we are driving on 80 feet road, and some of the situation we will encounter that okay, 80 feet road has gone and 20 feet road has came in the mid only. It's like you are running. So it will give you a situation where only one car can pass through. Anybody encountered this situation? Right, everybody. So this is kind of same situation. We have this train track in altogether different directions, but it's made in such a way that no time any two trains can travel in two different directions.
Semaphores.
Yeah, semaphore is one of the law. So Python is using that binary mutex. So here we came again. So that four threads are working parallelly, but it's not actual parallelism. It's like it will work only when it will find the lock. Let's say Python interpreter is running and it has a lock, and then okay, thread 1 has acquired that lock, so go ahead. When some other IO operation has to perform, and then thread 1 will give up this CPU till and it will go to waiting state, right? We talked about so it will go to waiting state, and then that IO till the time IO is performing, another thread can take that lock, and then this lock increase and again acquiring release is happening all the time. So since this lock, and the problem is here when you are having multiple CPU, your CPU, since operating system is responsible for giving the resources to your programs, right? So what operating system will find, like, okay, I have 4 CPU, so I have one sitting idle, I'll give you. So the thread went and then say, okay, I got the CPU but not the lock. I got the CPU to execute but Python is not giving me the lock, then how I will be able to run my program, run my thread? So in case of when it is, did you understand that, okay, if it is an IO bound operation, lot of IO bound operation in your program, then you will find it beneficial. But what the program I showed you, that was CPU bound task. So let's say in CPU bound task, nobody is going to do any IO operation. Then who will give the lock to the another thread when one thread is running for, let's say, 1 hour? So until it will not execute full, nobody will get it, right? So Python interpreter has its own way of tackling with the situation. It's like check interval. So every 100 ticks, default is 100, you can set it. So every 100 ticks, it is trying to check whether that GIL is available to me. I want that GIL. I want that GIL. And this, in terms of getting that GIL, lot of battle is happening. So this is the situation how CPU bound task is operated in one CPU and multiple CPU. I talk about this legend, like the white is idle and green shows running time, and then the red one is when it failed to acquire GIL. So what happens when I was having one CPU only? So it was able to, so operating system has said, okay, no CPU is available, you can't do anything. Okay, fine. Then when thread 1 has dropped the GIL, the CPU was available to thread 2, and thread 2 was able to execute its operation, right? no battle is happening here. Okay, I want GIL, I want GIL, I want GIL. But in case of two CPU, the operating system is saying, okay, thread 2, go ahead, I have CPU resources for you. But the Python interpreter is saying, no, I can't give you. The thread 1 is running. So here the red, you are saying that is failed to acquire the GIL. And this battle has dragged your performance in the program and showed you. This battle of acquiring GIL and releasing GIL. Then if these all battle is happening, then why GIL is required? So if we have locked it here, no unthread safe, code will go inside, or if it is going, no problem. It's already been locked. Nothing will happen if at a single time only one thread will be executed. So the single threaded programs will perform better. And easy integration of C library, which is not thread safe, and it's faster if you will achieve performance if your program is having high amount of operations. Can't we get rid of this thing? People have tried earlier. So they found that POSIX has not done well in that if you have removed that GIL, then so it didn't work well. But again in Python 3.2 some enhancement has been done, and then we'll see how it works. So okay, so if we have not achieved the performance, and we know that okay, we will be able to achieve it if it's a high bound operation. So again, I have one demo for you. So here I have list of code which I have used, and I have put it in GitHub. You will be able to see that. So I'll be running one of the tests. Should I close this stop?
What is code is morning a thread or
What?
something?
My threading you are talking about?
Yeah.
Okay, the number 1, 2, 3, 4. That is thread number of threads we are trying to execute in the same program. I'll show you the program what it does. So here the earlier program I have showed you that is having 100 million number it was trying to count down. And this is the same program, but it is having some 10 million. So it is taking 0.8 second in case of 2.7. But it is taking 0.9 in case of 3.6, same program. So what they did with the GIL, they introduced some of the global variable, and then it's recursively, it's not recursively, it's periodically checks that whether the GIL is there or not. I didn't look in much detail, but the problem is it's like 3.6 is even getting worse in this case of CPU mode operations. So if you will see that multi-threaded program, I have a same one thread only, then it is giving me the same time. But if I have increased 2 threads, it is giving me less performance. And when I did the empty spin, I told you about that spin of the CPU and then use that single processor to execute. It is giving me 0.58. right? And then I tried multiple threads, 4, 6, 8, 16, but I was not able to achieve performance. So here with the same Python 3.6, it is nowhere, I mean every log is getting more time in respect to Python 2.7. So then what about the performance? How will we achieve in case of CPU bound operation? Any clue?
Multiprocess.
Hyper-threading. Oh, hyper-threading is a concept in, it's like hyper-threading, you will be able to achieve in Python.
I mean, these CPU, then they will be hyper-threaded.
Okay.
It will be executing the virtual code rather than this.
Okay. So any clue again?
CPU affinity.
CPU affinity. But what about the rest thread? They will be talking about. I mean, they will be waiting, right? If you will give CPU affinity to one of your thread, the other thread will be waiting, right? So I have one idea. So this is multiprocessing. So that is able to achieve performance in case of Python. So here, one thread was the same time 0.8, but as soon as I have divided this code to use to spawn to process, it's going to be hard. So now the problem is like, can you divide your program to process? So it's like you will achieve performance, but can you divide your program to two different processes, because process is independent of each other, and thread was sharing your memory inside that process. So it can be done if you are writing to some of the your data, which can be taken care at that with two different processes, which is not right. So a lot of it is like your one of the program which is writing at the same data. That point you will lock using Python threading lock, and lock before that data is being written, and then release that lock while you are getting out of it. So multiprocessing is the way. So I will show you here that code also. So this is the multiprocessing thing I have done here. Right? How many process I can I want to. So I have used multiprocessing library. So start and join till process executes. Right. So the conclusion is like you just use your way to lock your data and then do spawn multiprocessing.
Is there any sharing between this multiprocess at this point? I mean, it's like if you're multiprocess, for example, you are doing a database operation where you are writing into a database.
So when you are writing to the database, there will be a fine-grained lock. Whenever you are writing, that time the lock will happen, and then release that lock when the transaction is completed. Right? It's a fine-grained lock in your code level. It's like the statement you are writing, this one, right? Here put the lock, and when it's done, release the lock. But in case of Python, your interpreter is itself locked.
So for initial issue, what's your view on the cache misses, because you are using the multiple cores and the way operating system caches this and the multiple processes. When you use the thread which is the same variable which is modified by some other CPU, so in that case the cache it will be less. The whole patterning has to be redone. That's the issue. You are getting the performance issue there. Instead of executing in a single CPU 8 seconds, you are taking 10 seconds. So your issue is with the way that you are processing the data itself.
No, I don't have any. So it was having just an integer which we are decrementing, right?
Yeah, correct.
So the problem it happened when I said Python do this, decrement that number from this 100 million to 0, and I have sent one thread was okay, 2/3 I said, okay, you do 50 million, you do 50 million. So there was no I operation happening.
Correct. But the cache which is created for the CPU1, CPU2, if CPU1 the thread executing decrementing the value, and now it sees that the value has been changed in CPU1, then now what is the cache it has
So
created has to be flashed.
these two data, 50 million, 50 million, these are two different operations, different data point. It's not shared. It's not shared, right? If you will talk about, okay, so if you will talk about 100 million, so that 100 million every two, I have, divided your work into two parts. That's what I did. So do I have something to remove GIL? Yeah. Yes.
And we want to multi-threading. So can't Python make a new instance of its interpreter and give it to...
That's what multiprocessing is doing. So that it is giving you another process. It was locking on the process itself, right? That process, the interpreter process was locked. But multiprocessing is giving you to spawn some different interpreter for different work. That's how you are achieving performance. Otherwise, not.
I guess what it turns out to be is what do you want to achieve? Do you want to achieve concurrency or do you want to achieve parallelism?
Okay. So
Okay,
concurrency
the
is.
point most of the enterprise applications, what they want to achieve is they want to achieve both at times.
Okay.
So parallelism is not essentially turns out to be concurrency.
Okay. So yeah, actually, when you talk about concurrency, so in the fine-grained level, it will be having a lock every time, right? If you are accessing shared data, right? So parallelism is like, okay, how much, how fine-grained lock we can put, and how the other time we can utilize. So let's say 1 minute of your CPU resource, it was having only 1 second lock time. So 59 seconds you do it for parallel, and 1 second let it be locked, right? So if you have two process, if you have one process which is taking 1 minute and only 1 second lock thing is there, if you will have two process running, so even you will take 1 minute, 1 second, 3 process, 1 minute, 2 seconds, right? So the lock time is only increased.
But it comes with a baggage, right? Multi-processing,
That you need some memory space, right? So how can we remove GIL? There was a video on YouTube by David Beasley. You talked about David Beasley. Sorry.
All right, David Beasley here. I'm going to show everybody how to remove the GIL using Python 3. Let's start up Python 3. I'm going to import GIL. Let's do remove GIL. All right, everybody ready for this? That's how we do that. Let's take a look. There we go.
Thank you. So any more questions? Okay.
You mentioned the point that there are few C libraries referred in the Python which are thread unsafe, right? So is there any way to make them thread safe in Python?
Oh, okay. So you need to go again rewrite that library and then use it.
How the resource will be shared if you make one process out of your Python program?
sorts will be shared among these two processes?
Okay,
Because
so, one, when you started running Python empty string processing.py, one process has started, right? So when you spawn multiple processes, that will be the child process of that process.